All right. We can apply L'Hopital's rule to find the limit of a sequence in the same way we apply L'Hopital's rule to find the limit of a function. So I'm guessing we did that in Unit 1. L'Hopital rule was covered in Unit 1. Suppose that we have that the limit of f of x over g of x as x approaches a is equal to 0 over 0 or any other indeterminate form, then the limit of f of x over g of x as x approaches a would be equal to the limit of the first derivative of f of x divided by the first derivative of g of x as x approaches a. If we have an indeterminate form, we can find the limit by differentiating the numerator and the denominator and then take the limit If the new function is still indeterminate, we can differentiate again and evaluate the limit. This is L'Hopital's rule. All right, very quickly, try example 13. All right, so example 13 is asking us to determine whether the function un, which is equal to 6n over 2n minus 1 converges, and find its limit if it does converge. All right, to determine if it converges, we need to find the limit to infinity of un, which would be equal to the lim as n approaches infinity of 6n over n, 2n over n minus 1, which would be the limit as n approaches infinity of 6 over 2 minus, this should be 1 over n, 1 over n. Then by direct substitution, this would be 6 over 2 minus 1 over infinity, which is 6 over 2 minus 0, which is 6 over 2, which is equal to 3. So does un, so therefore un converges to 3. Un converges, yes, and it converges to 3. All right, for homework, please do exercise 7A. I said odd numbers, but do all questions. All questions. Homework exercise 7A, do all questions.